Hello again, it's Miss D. Today, we will be looking at how we can add mixed units of length. Let's get started by looking at slide B. So for this slide, they want you to rewrite the sum for each problem below, then look at the sums. What do you notice? What do you wonder? Go ahead and answer these questions. When you're ready, go ahead and unpause. So here they want us to rewrite 8/12 plus 7/12 equals 15/12 in 2 months. So if we think about months and years, how much is 15/12? Well, we know that a year is made up of 12 months, right? So we can write a whole year as 12 out of the 12 months. But to get to 15/12, we still need another 3/12. So we can rewrite this as 1 year and 3 months. All right, let's look at the second part. 8 inches plus 7 inches equals 15 inches, and they want us to express 15 inches as feet and inches. So here we also know that 1 foot equals 12 inches, right? Instead of writing 1 foot, we can write 12 out of 12 to show that there are 12 inches in 1 foot. But we still need 3 more inches. So that's 3 out of the 12 to make a foot. So we can say our answer is 1 foot and 3 inches. So very similar to the previous lessons that we looked at. We want to combine units, and then we can also convert units so that we can rewrite our answer, our sum here, into larger units. So what did you notice? What did you wonder? Did you notice that we are adding 8 and 7 both segments? Did you notice the units are different? So here we're talking about 12ths, really years and months, right? And here we're talking about feet and inches. What did you wonder? Did you wonder if we can rename the answers a different way? So here was the way we changed the answers, right? We changed the sum of 15/12 into years and months. We changed here the answer 15 inches into feet and inches. All right, we're going to go ahead and slide down to the next slide. Whoops, went a little too far there. Let me just go up. Okay. So, notice and wonder again. Consider the two different ways of adding 8 inches and 7 inches. Analyze them. What do you notice? What do you wonder? So it's still those same numbers. We're going from 8 inches plus 7 inches, and we're going to get that 1 foot 3 inches. But I want you to notice the two different ways that that problem was solved. So go ahead and answer those questions, and when you're ready, you can go ahead and unpause. So what did you notice? Did you notice they got the same answer but solved different ways? Did you notice that one student counted up so they knew if we have 8 inches, if I add 4 more inches, it'll take me to a foot. And then if I add 3 more inches, it'll take me to that 1 foot 3 inches. Did you notice that the other student created a number bond, so they combined 8 and 7 inches? Where here they broke the 7 inches apart, they just added them together, got 15 inches, and then kind of did what we did, right? We create a number bond. I know there are 12 inches in a foot, and I know that there's 3 more inches to get me back to 15, so that's 1 foot 3 inches. What did you wonder? Did you wonder if maybe you can always use both of those methods to add mixed units of length? Yeah, we can use both of those. Sometimes we feel a little bit more comfortable just counting up to the next unit, so we know we need to add 4 more to get to feet. And sometimes we just like to get that answer first and kind of break it apart. Either way will work. All right, now that we've seen two different ways we can tackle these kinds of problems, let's go ahead and take a look at this problem here. So it says here, answer the questions on the right one at a time. Read the story again before you answer a question. You should read the story at least 3 times. So let's go ahead and read it, our problem 7, then we'll answer that first question. A sign next to the roller coaster says the person must be 54 inches tall to ride. At his last doctor's visit, Heather was 4 feet 4 inches tall. He has grown 3 inches since then. So what is happening in the story? Yeah. We know that you have to be a certain height to ride a roller coaster, right? Heather is 4 feet 4 inches tall. His last doctor's appointment, we know he's grown 3 inches since then. Seems like he's going to go to some sort of amusement park, right? All good answers. All right, let's go ahead and take a look at the next part here. So we're going to answer these 2 questions in a moment. Let's go ahead and read that problem stem again. A sign next to the roller coaster says a person must be 54 inches tall to ride. At his last doctor's appointment, his last doctor's visit, Heather was 4 feet 4 inches tall. He has grown 3 inches since then. So what are the quantities in the problem? You can use those sentence starters. I can count, I can measure to help you along the way, and also answer the question, what relationships exist? So go ahead and answer those 2 questions. When you're ready, you can go ahead and unpause. So what are the quantities? Well, we can count that there is 1 roller coaster, there is 1 boy, right? We can measure how tall you have to be on the roller coaster, right? You have to be 54 inches. We can measure how tall Heather is, right? He's 4 feet 4 inches at his last doctor's appointment. And we also know he grew 3 inches. And what relationships exist? What did you come up with? Yeah, we know that there are 12 inches in a foot. I know that if you are 54 inches tall, you are tall enough to ride the roller coaster, right? So 54 inches equals you're good to go on that ride, right? It will be 54 or greater. So we know that that's a relationship between your height and the roller coaster. All right, ready for that last question? Let's read this problem and then we'll see what that last question is. A sign next to the roller coaster says a person must be 54 inches tall to ride. At his last doctor's visit, Heather was 4 feet 4 inches tall. He has grown 3 inches since then. Final question. What are some mathematical questions you could ask about this problem? So go ahead and come up with some questions you can ask based on the information that was given here. All right, let's take a look at a few questions here. Is Heather tall enough to ride the roller coaster? Is that a question you came up with? Maybe the question was how many inches tall is Heather? Maybe your question might have been how tall is Heather now? These are all great questions that we can answer based on the information that was given to us. All right, before we actually find out what the question is, let's see if we could draw something that can help us see or understand those relationships better. So think about the quantities and relationships. How can you represent these? So again, we'll read it one final time here before we take a look at the question. A sign next to the roller coaster says a person must be 54 inches tall to ride. At his last doctor's visit, Heather was 4 feet 4 inches tall. He has grown 3 inches since then. What can you draw? You can go ahead and use the graph paper if you want, or you could just sketch something on your own. So go ahead and draw something that would help you see those quantities and relationships better. When you're ready, you can go ahead and unpause. So what did you come up with? Did you maybe draw a little bar model to show the relationship between feet and inches? We know that 1 foot is made up of 12 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches here. And that is equivalent to 1 foot. So that means if he's 2 feet, that would be 24. You might be thinking back to a table that you saw in the reference slides for this lesson, which you could also use to help you solve this problem. All right, let's go ahead and take a look at the question. You ready? All right, let's read it. A sign next to the roller coaster says a person must be 54 inches tall to ride. At his last doctor's visit, Heather was 4 feet 4 inches tall. He has grown 3 inches since then. Is Heather tall enough to ride the roller coaster? By how many inches does he make or miss the minimum height? All right, so this kind of was similar to one of our questions, but we see it's 2 questions here that we have to answer. So go ahead and answer this problem. When you're ready, go ahead and unpause. All right, let's take a look at one way we could have solved this problem. So one of the ways that we could have solved this was to use a table. So we know that he is 4 feet 4 inches at his last doctor's visit. So we know that 4 feet is equal to 48 inches, right? If we were talking a moment ago about 1 foot being 12 inches, we then know that 2 feet is 24 inches, and then we could double the 2 feet to bring us to 4 feet. When we double the feet, we also double the inches, so we have 48 inches here. So we still need to add the 4 inches from his doctor's visit, so 48 inches plus 4 brings us to 52. And then since then, he grew another 3 inches. So once we get that 52, we have to add the 3 other inches that he grew from after the doctor's appointment, and that gives us a total of 55 inches. Is that what you got? Yeah, so he did make the ride, right? Now the second part of that question, don't forget there was a second part. By how many inches does he make or miss the minimum height? He made it by an extra inch too, right? He had to be 54. He was actually an inch even taller than he needed to be, right? Let's take a look at it. Maybe you solved it a different way. Let's take a look at another way a student solved it. So here we have student B who wrote 4 feet 4 inches plus 3 inches equals 4 feet 7 inches, which equals 4 times 12 inches plus 7 inches, which equals 55 inches. However, is tall enough by 1 inch. So go ahead and answer those 3 questions before we finish this up. When you're ready, you can go ahead and unpause. So what did you notice? This was a little different than the previous one, right? A lot of numbers here. So did you notice that student B added the inches together? So did you notice that they did 4 feet 4 inches plus 3 inches? When we combine the inches, it gives us 4 feet 7 inches. Did you notice that student B multiplied the 4 feet? So they took the 4 feet here and multiplied it by 12 inches. Why did they do that? And then they added 7 inches and got 55. That's what we got before, right? What did you wonder? Did you wonder why student B multiplied 4 by 12? We didn't see that in our table. That's not the way we looked at it, right? But remember, we spoke about this when we were studying converting from larger units to smaller units. If we know that the rule is, well, that 1 foot equals 12 inches, and let's say 2 feet equals 24 inches, how do we get from 1 to 12, from 2 to 24? And the rule there is that we take the feet and we multiply it by the 12 inches. Okay, so we take whatever number of feet we have and we multiply it by 12 inches. So that's our rule, and that's what this student used. They used the rule, okay, I know that 1 foot is 12 inches, so 4 feet would be that 12 inches, which was the same answer we got in our table. 48 inches plus the 7 inches gives us that 55 inches. And he is tall enough by 1 inch, right? So he exceeds what the requirement is by 1 inch. What does this make you think about problems involving the addition of mixed units of length? Did this make you think that you can solve addition of mixed units of length different ways? Did you notice that you can make a table to convert, or you can use the rule, in this case, multiply by 12? Yeah, there are many different ways that you can solve these problems. We were able to explore 2 of the ways here, using a table and using the rules to help us solve these addition problems of mixed units of length. All right, and final thing, you go ahead and compare the students' thinking here. How are they similar? How are they different? And what mathematical conclusions can you draw about solving word problems involving addition of mixed units of length? Go ahead and solve those questions and then we'll wrap up for today. All right, so how is their thinking similar? Did you notice that they both converted the feet into inches by multiplying? We don't really see it here in the table for student in the work for student A, but we know that in order to go from 4 to 48, we have to multiply by 12. They both got the 55 inches as Heather's height. How was their work different? Well, student A used the table, right? They used the table from the reference slides to help them figure out this problem. They just took a portion of that slide, the 4 feet equals 48 inches, and added those additional 7 inches to get their answer. While student B used an equation and the rule multiplied by 12 to help them solve the problem. What mathematical conclusions can you draw about solving word problems involving addition of mixed units of length? Well, we can come to the conclusion we can use tables to convert units of measurement, or you can use the relationships of units to help you solve addition of mixed units of length. So in this case, we can use the 4 times 12 inches to help us figure out how many inches 4 feet is. Right? So those are the different ways that we explored today. So I hope you found this video helpful on how you can add mixed units of length. Great job, and I'll see you next time. Bye, everyone.